This refers to a specific class, Sklearn, within the Sklearn machine learning library. I'll focus on understanding what it does. This statement says that Sklearn has a convenient method called FIT. This method does two things at once. It trains the model, FIT, and then immediately uses the trained model to predict which cluster each data point belongs to, PREDICT. That's super efficient. This means Sklearn isn't something you can directly use to build a clustering model. Think of it like a template or a blueprint. It defines what a clustering algorithm should have, like methods for training and predicting. But you need a concrete implementation, like k-means or dbSCAN, built upon it. This is crucial because BASEESTIMATOR is a foundational class in SCIKITLEARN. By inheriting from it, Sklearn guarantees compatibility with other SCIKITLEARN tools and workflows. It plays nicely with other parts of the library. This is a bit tricky. While a FIT method is essential for any useful clustering algorithm, Sklearn itself doesn't actually require its implementation. It expects concrete implementations, like k-means, etc., which inherit from it, to implement their own FIT methods. This is the question I am addressing. It's asking you to identify the correct statements about the Sklearn class. I've carefully examined each option to provide explanations. This question asks you to identify the characteristics of the cluster Mixin class, a crucial part of scikit-learn's clustering tools. It tests your understanding of its functionality and how it's used in machine learning. Let's dive in. I can confirm that's correct. An abstract base class like cluster Mixin provides a blueprint for other classes. You can't use it directly. Instead, other clustering algorithms, like k-means or dbSCAN, inherit from it to get its features. Think of it as a template. You need to build something from that template to actually use it. This is true. Base estimator is a base class in scikit-learn that provides a standard structure for machine learning models. Cluster Mixin inheriting from it ensures seamless integration with other scikit-learn components, like pipelines and model evaluation tools. It's designed for interoperability and consistency within the scikit-learn ecosystem. Yes, that's also accurate. The _fit_predict method is a very convenient feature of cluster Mixin It combines model training, fit and prediction of cluster labels, predict into a single step. It saves you from doing those two steps separately. This statement is a bit misleading. While cluster Mixin expects subclasses, like k-means, to have a fit method for training, it doesn't enforce this directly. The fit method is implemented by the concrete clustering algorithms that use cluster Mixin not by cluster Mixin itself. I'm assessing your understanding of the Sklearn cluster Mixin class in scikit-learn, a popular machine learning library in Python. This class is a crucial part of scikit-learn's clustering capabilities. We'll examine several statements to determine their accuracy regarding this class. Correct. Cluster Mixin is in abstract base class. Think of it as a blueprint or a template. You can't directly use it to create a clustering model. Instead, other concrete classes, like k-means or dbSCAN inherit from it, adopting its common interface. Absolutely. Cluster Mixin inherits from base estimator This is very important, because it ensures compatibility with other parts of the scikit-learn ecosystem. It allows you to seamlessly integrate clustering models into pipelines, model selection, and other scikit-learn tools. This is the subject of our quiz, focusing on the cluster Mixin class within the scikit-learn library for clustering. Let's explore what this class does and how it's used. That's right. Cluster Mixin conveniently provides a fit_predict method. This single method both trains the clustering model on your data, fit, and predicts cluster assignments for your data points. Predict, all at once. It combines two separate steps into one. This quiz tests my knowledge of the Sklearn class in the Sklearn library. I need to understand what it does and how it works. The question asks me to identify accurate statements about Sklearn. I need to carefully consider each option provided. This statement is partially true, but I see a nuance. Sklearn itself doesn't require a fit method. Instead, it expects that any class inheriting from it will implement a fit method. The fit method is crucial for training the clustering model. However, the actual implementation happens in the classes that extend Sklearn, such as k-means or dbscan. This statement is correct. An abstract base class serves as a blueprint. It defines a structure and interface but can't be used as a standalone object. It's like a recipe. You use the recipe to create, instantiate, a cake, concrete class, but you can't eat the recipe itself. This is also correct. Inheriting from BASESTIMATOR ensures that CLUSTERMIXIN plays nicely with other SCIKITLEARN components. It's like making sure a building's plumbing, a class, is compatible with the electrical system, another class. This is true. CLUSTERMIXIN often includes a convenient FITPREDICT method to simplify the process. I'm combining the fit, training, and predict labeling steps. This refers to a specific class, cluster Mixin, within the popular Python machine learning library, Sklearn. It's a crucial component for building clustering algorithms. I'm telling you, this statement is true. The cluster Mixin class conveniently offers a fit_predict method. This single method does the work of both training the model, fit and then immediately predicting cluster assignments. Predict. It's a helpful shortcut. That's correct. Cluster Mixin is an abstract base class. Think of it as a blueprint or template. You can't use it directly to build a clustering model. You need to create a concrete class that extends it. Absolutely. Cluster Mixin inherits from base estimator. This is important because it ensures that cluster Mixin works seamlessly with other Sklearn tools and components. It's like fitting right in with the rest of the Sklearn family. Well, this one is a bit tricky. Cluster Mixin expects subclasses, like k-means or dbscan, to have a fit method, but it doesn't enforce it directly within its own definition. The actual fit method implementation lives in the specific clustering algorithms that inherit from cluster Mixin. I see that you're curious about whether cluster Mixin directly demands a fit method. The key here is that cluster Mixin is a blueprint. It sets the expectation that any class inheriting from it should have a fit method to train a model. But cluster Mixin itself doesn't enforce this. The concrete clustering algorithms, like k-means or dbscan, which inherit from cluster Mixin are the ones that actually implement the fit method. Think of it like a recipe that says you need flour. The recipe doesn't provide flour, but you will need it to bake the cake. The fit_predict method? That's a really convenient function that combines model fitting and prediction. First, it fits the clustering model to your data. Then, directly after fitting, it gives you the assigned cluster labels. It simplifies the process. No need to call two separate functions. Pretty neat, huh? This is crucial for compatibility. Cluster Mixin inherits from base estimator . This means that it plays nicely with other Sklearn tools. You can seamlessly use clustering algorithms within pipelines, use cross-validation, and generally integrate it with the broader Sklearn ecosystem without hiccups. It's like having a universal adapter for your tools. An abstract base class? That's a class that defines a common interface, methods, for subclasses but can't be used directly. You cannot create an object from it. Instead, you create objects from its subclasses. It's like a template or blueprint for creating concrete clustering algorithms. It ensures consistency. This is related to being an abstract base class. You cannot directly create an instance of cluster Mixin. It's a template. Think of it as a cookie cutter. You don't eat the cutter. You use it to make cookies, the actual clustering algorithms. The fit methods implementation lives in the concrete classes, those that specifically perform the clustering. Cluster Mixin just makes sure they follow the blueprint by having that function in their design. I see this as the core concept. It's a Mixin class in Sklearn, a popular Python library for machine learning. Think of it as a blueprint for clustering algorithms. It provides standard methods and behaviors, ensuring that all clustering algorithms in Sklearn work consistently. It's not something you use directly. Instead, other clustering algorithms, like k-means or dbSCAN, inherit from it to get its useful features. This means you can't create a cluster Mixin object on its own. It's designed to be a base for other classes, defining a common interface without providing full implementation. Think of it as a template or contract. It specifies the methods that its subclasses must implement. Subclasses are the algorithms we actually use. This is a method that cluster Mixin provides for convenience. It combines two steps. First, it fits the clustering model to your data, learning the patterns. Second, it predicts the cluster assignments for each data point. It's efficient because it does both in one go. This is important for compatibility. Base estimator is another Sklearn class that provides a standard structure for all estimators, models. By inheriting from it, cluster Mixin and its subclasses neatly integrate into the Sklearn ecosystem, allowing seamless use with other Sklearn tools and workflows. While the cluster Mixin expects its subclasses to have a fit method, it doesn't enforce it directly. The fit method is where the actual clustering model training happens, but the training itself is done in the subclasses that inherit from cluster Mixin. The cluster Mixin simply sets the expectation for a standard method name.